Hello students, I hope all of us are here. So all the centers who have joined, can you just say hi on the chat box so we can know you have joined? We have one message from Shillong. Okay, so we have Shillong with us. Do we have more centers joining in? Shillong students, I hope all of you are good. How is the weather there? Okay, let's start the class now. I'm Garima. I hope all of you love chemistry or at least are ready to study chemistry. So today we are going to study atomic structure. Nidhi ma'am must have taught you topics of this chapter up till photoelectric effect. Today we are going to study it after that. Okay. So basically today we are going to first revise the chapter, whatever we have studied till now, and then we are going to quickly solve some basic problems or questions from this chapter. This is because one of the major issues that students face in this chapter is that it's really big or really lengthy chapter. And it has a lot of concepts, so students get confused sometimes. Okay, so we're going to revise whatever we have studied till now, and then we're going to solve some questions. And this chapter is also very important from NEET point of view and even for other competitive exams, because a lot of questions are asked from this chapter and it has a lot of weightage. So if you study it well, your score of the exam will definitely be maximized. Okay, we also have Christukula joining us. Okay. So, starting this chapter, whatever we have studied till now, I think first of all we're going to study about the atomic structure and how we came up with the structure of the atom we know till now. You must have studied about Thomson's model, you must have studied about Rutherford's model, and you must have studied basics about Bohr's model in your earlier classes. Okay. And in this chapter till now, what we must have studied is, first of all, how cathode ray experiment helped us in introducing or in telling us what the structure of the atom is and what are the subatomic particles present in it. Okay, we came to know that there are electrons present in the atom. Then protons came around and Chadwick discovered neutrons. So this is how we came to know that an atom is actually divisible and has electrons, protons and neutrons. Okay, so the first type of questions that we're going to do are very simple. They are based on finding out the number of electrons, protons and neutrons that you have in an atom. Okay, so the two terms that we're going to first deal with here are, if you find the writing not writing very messy, please just let me know. I will try to be a little more legible. Okay, atomic number, and then we will have mass number. Okay, I hope all of you have studied about this and remember this. If you do, can you just quickly tell me in the chat box what do you remember from atomic number and what do you remember from mass number? What do both of these terms mean? So up till now we have Shillong and Christukula being active. If there are any more centers, please just send a hi so we know you are present. Okay, Kohima. Kohima says atomic number is the number of protons. Correct? Very good. So we can write this down. So atomic number is the total number of protons present in an atom, or we can say in the nucleus of an atom. Okay, protons are always present in nucleus of the atom. Then we have Christokula answering mass number is the total mass of an atom. Okay. क्या हुआ?
यहाँ से लिखोगे ना, नहीं कट रहा है वो देखो.
ओह ओके, ठीक है.
यहाँ से.
ठीक है.
जो ग्रीन ब्लू वाला नहीं है.
हाँ ठीक है.
ये ग्रीन.
ठीक है.
हाँ.
Okay. So Christokula, you answered mass number is the total mass of an atom. This is slightly incorrect. We will see how. Kohima says mass number is the total number of electrons and protons. Okay, neutron is equal to proton. Okay. So I think some of the students are slightly confused here in this topic. Let me just write this down for you. Mass number of an atom is actually equal to the total number of protons in an atom plus total number of neutrons in an atom. Okay? So it's actually the number of protons plus the number of neutrons that are present in the nucleus of an atom. Okay. Christokula, you answered that mass number is the total mass of an atom. Okay. So it's actually slightly incorrect because in mass number we do not have any term occurring for electrons. And although electrons have very small mass, but they still have mass. So sometimes we make the approximation that mass number is equal to the actual mass, but in some questions you can be asked otherwise, so don't get confused between these two topics. Okay, Shillong answered correct, total number of protons and neutrons. Okay, so I think all of us are on the same page here. One more quick question that I have for you is atomic number also equal to the number of electrons that we have or not? If I say that atomic number is equal to the total number of electrons, then is this correct or is it incorrect? Okay. Kohima says yes. Shillong says yes. Christokula, can we also have an answer from you? This is a slightly trickier question, by the way, so if you want to think on it and maybe change your answer, you can. Okay, Christokula, we're waiting for your answer. Okay, Christokula says incorrect because electron transfer takes place. This is actually correct. So, and it was a trickier question, so no problem even for students who are confused in this. Let me just explain this to you. See, first of all, the total number of electrons is equal to the total number of protons only if we have a neutral atom. Okay, this means I have an atom that doesn't have any charge on it. Okay, which means it's okay if I have Li, if I have Fe, if I have copper, etc. But if I have an ion forming like Li plus, Fe2 plus, copper 2 plus, then this statement is wrong. Okay? Why? Because let us consider the case of lithium. Okay, I have lithium atom, which is basically a neutral atom, and then I have a lithium ion, let's say. consider both of these. What is the atomic number of Li? It's 3. Okay. Li plus also has atomic number 3. Okay. Atomic number does not change even when an atom becomes an ion. Atomic number is an inherent property of an element. So it always remains the same. Okay. So the atomic number of lithium or lithium ion is always going to be the same, which is equal to 3. So now let us compare the number of protons and electrons that we have here. What will be the number of protons in lithium atom? It will be 3. What will be the number of electrons? It will be 3. Why? Because I have no charge. Okay, it is a neutral atom. Now for lithium plus, what will be the number of protons? 3. Because atomic number is 3, so the number of protons is 3 always. But now what is the number of electrons? You see that it has a positive charge on it. This means that it is devoid of one electron. Since the charge is 1 plus, it means it has given its one electron. So therefore now it has only 2 electrons left with it. Okay, Kohima answered correct, 2. Okay, so but now if you see, the number of electrons is not equal to the number of protons in this case, and therefore if I write down 2 as my atomic number here, it will be incorrect. So always atomic number is the number of protons in the atom. It is equal to the number of electrons only if I have a neutral atom. If it's an ion, the number will be different. It can be more or it can be less. Don't get confused in this. Okay? Have all of you now understood this? Yes or no? Please just let me know quickly so we can move ahead. Or if you have any problem, let me know. I can again discuss one more problem here. Okay. Kohima, Kristukula have understood. Shillong students, we can see you, so you can also raise your hand. Okay, yes, Shillong has also understood. Great. Let us now move ahead. I'm going to quickly give you a question based on this concept. Okay, before moving ahead, one more thing. Are you students aware? I'm sure you must have read this. Just let me know if you're aware with this notation. So are you all aware of the notation where we represent an element like this, where basically A is the mass number and Z is the atomic number? Yes, okay. I have students answering that they're aware of this. Great. So now I'm going to give you some questions based on this concept. First question, very simple, is you have to tell me the number of protons, neutrons and electrons present in Br. Okay? I hope all of you can read the question. If you can't, just let me know. You have to tell me what is the number of protons, neutrons and electrons present in Br 8035. Okay? So I'm giving you 2 minutes. Quickly solve this question and let me know the answer. Okay. We have Shillong answering, Kohima answering. Okay. Okay. Kohima, first you wrote proton and neutron is 35 and 35. I think you meant to say proton and electron is 35 and 35. Okay, we have Kristukul also answering correct. Great. So I think all of you know this. Quickly, just to ensure all of us are on the same page. you are given 80, Br 35. This, you have to do nothing. This is the number, atomic number, which is equal to the number of protons. So I have 35 protons. Now since my atom is neutral, there is no charge indicated on it. This means this is also equal to the number of electrons that I have. Now 80 is my mass number, which means 80 is equals to number of protons plus number of neutrons. I'm sorry, there will be no negative charge on neutrons. Okay. Number of protons plus neutrons. This is equals to 35 plus n. You solve this equation for n and you will get number of protons as 45. So all of you gave the correct answer. Good. Let us move on. Quickly solving one more question. Again, tell me the number of protons, electrons and neutrons in uranium. Okay, I hope you know U stands for uranium. In 238, uranium 92. Students, I hope you understand this very well. It is actually an important concept from exam point of view. You can be given such a notation for elements and can be asked its proton, neutron, electrons, or sometimes you can also be given a lot of different elements and then can be asked questions based on it. Like which of these elements have same number of protons, have the same number of electrons and so on. We are going to practice them also today. Okay, we have Shillong answering, Kohima answering. Okay. Great. Christokula has also answered and all of you are correct. So atomic number we have 92. At mass number is 238. So number of protons is 92. Since there is no charge on it, so electrons are also 92. And neutrons would be 238 minus 92 is equals to 146, which all of you have answered. Great. So let us move on to the next concept. We'll come back to some more complicated problems on this concept later in the class. First, let us try to solve all the easier ones from the concepts that you have studied. Okay, so it's kind of a warm-up for all of you. Okay. Same concept, slightly different question. In this question, it's actually the reverse kind of a question. You are given the number of electrons, protons and neutrons in a species is equals to 18, 16 and 16. You have to assign a proper symbol to the species. How will you write down this species? Okay. So in the chat box, you can just simply write this down as, let's say, whatever, 24x14 or whatever it is. Okay. In the chat box, you can give me the answer is in this form. I will understand from this that 24 is going to be your mass number and this will be your atomic number. Okay, great. Kohima has answered. Okay, we have Christokula answering. Okay, Christokula, your answer is correct. Can you just, since your answer is correct, can you also tell me which element it is, if you can? Okay, Shillong, if you're waiting for your answer. Great. Christokula, correct. Shillong says S2 minus. Okay. So, all of you gave the right answer. Okay, all of you said it's sulfur, which is correct. But only Shillong said it's actually S2 minus. So Shillong wins this one. Now why? Let us see. You have the number of electrons is equals to 18 and the number of protons as 16. So here if you see, you actually have more number of electrons than protons, which means that your element is going to have negative charge. And how much of negative charge? -2. Okay, so all of you came to the answer S. Just one thing that you missed is it's going to be S2 minus. Okay. Students, if you already knew this very well, if you didn't, please don't repeat this mistake in the exam. Okay. It's a tricky question, so the examiner is always going to give you S in the option as well as S2 minus. If you choose S, it's going to be incorrect. Okay. Please ensure this, that you look up at all of the options correctly and then choose your answer as S2 minus. Are we clear about this? Students, if you have any question up till now, please let me know. Okay, I think okay, all the students have understood, so let us move ahead. Now we are going to move ahead and study about some quantities like wavelength, wave number, frequency. Okay, so the formulas that you must have already studied are C is equals to nu lambda, where C is speed, nu is frequency, and lambda is wavelength. Okay. Also, one more equation that you must have studied is wave number is equals to 1 by lambda. So the inverse of wavelength is called wave number. Okay, so quickly just read these formulas. And now we are going to solve some questions based on these. If you want, you can write these down on the top of the paper so that they're handy when you're solving the numericals. Okay, moving ahead. The first question is, you have to calculate wave number and frequency of yellow radiation that has wavelength of 5800 angstroms. Okay, so the wavelength is given to you as 5800 angstroms, and you have to calculate the wave number and frequency. Okay, we have also told you that the radiation that we're talking about is yellow. So it's in the visible spectrum. Okay, so quickly solve this and let me know the answer when you're done. Also, in such questions, one thing that you have to remember is always pay attention to the units. For example, here you're given angstroms. Whatever formula you're going to use, most of the formulas have SI unit in them, which means when you're converting wave number or frequency or wavelength or whatever you're finding, always pay attention to the units, otherwise your answer can be incorrect. And the examiners are also very intelligent. They give you all of these options. Okay, if some of you have already solved this, here's the next question for you. Okay, we have some centers giving the answer. Okay, Christukula and Kohima have given the answers. Kohima, your answer is actually correct. Just check your power of 10 once. It's a little incorrect. Okay, just again see if you have done the power of 10 correct or not. Kohima, Christukula, I think you also need to check your power of 10 once. Okay, Kohima correct. Now you have the correct answer. Christukula, can you also cross-check your answer once? So students, I think the mistake that you're making here is you're not converting the wavelength given to you into SI units. Please just ensure that you do that. Okay, Christukula, I'm giving a quick solution here for you. The wavelength that you are given is actually equal to 5800 into 10 to the power minus 10 meters. Okay, please remember this conversion. Angstrom is actually equal to minus 10 meters. So the wave number that you're going to get will be 1 by 5800 into 10 to the power minus 10. And this will come out to be 1.72 into 10 to the power 6 per meters. Okay. So students who didn't get this answer, please check again once. And in the meantime, Shillong, if you've attempted the second question, you can post the answer for that as well. Shillong, okay, great answer. Shillong, correct answer for the second one. However, you forgot to mention the units. Please do that. Shillong, I think your numerical values are correct, but the place of the decimal is incorrect, and you will also have some power of 10 coming up in the answer. Okay, so just check that once. Kohima, correct answer for this. Christukula, correct answer. Great. Okay. So, quickly solving the first part of the question, we have to find out frequency. Okay, so we know C is equals to nu lambda. This implies frequency is equals to C upon lambda, which is equals to 3 into 10 to the power 8 upon 6,000 into 10 to the power minus 10 meters. Okay, students, just pay attention to the units. And this will come out to be 5 into 10 to the power 14 second inverse or per seconds. Okay, Shillong, great. Now you have given the correct answer. Okay, students, so how will you calculate the energy of the photon? We already have an answer from Shillong. To give you a hint, E or energy is equals to H nu. This is the formula that we're supposed to apply here. Christukula and Kohima, I hope you're able to solve the question. Okay, Kohima, give us an answer. What do you receive? Answer for the energy of the photon. Okay, great. Christukula, correct answer. So how you're supposed to do this is just plug in the values. For H you have 6.625 into 10 to the power minus 34 joule seconds into frequency, which is given to you, which you have found out in the previous part, 5 into 10 to the power 14 per second. And you get the answer as 3.31 into 10 to the power minus 19 joules. Okay, so if some of you have given the answer as 33.1 into 10 to the power minus 20 joules, that is also correct. Okay, so students, your answer is correct. Just pay attention to your unit ones. Okay, I'm sure all of you know that. You're just not mentioning it here. But most of the times what happens is that examiner, just to confuse you, can give you same answer with different units also. For instance, for this I could have given you options like 3.31 into 10 to the power minus 19 joules, which is the correct answer, or 3.31 into 10 to the power minus 19 second inverse. Similarly, I could have given you hertz or any different unit. Okay, and if such a question comes, there is a very simple trick for you to solve the MCQ. You don't even have to solve the question, complete question. You're supposed to find out the energy. Energy is always in joules, which means your this option is correct. Okay, so sometimes if you get MCQs of this kind, which has the same value but different units, all you need to do is find the unit. Okay, moving ahead. Calculate the kinetic energy of the electron ejected when a yellow light of frequency 5.2 into 10 to the power 14 per second falls on the surface of potassium metal. You are given that the threshold frequency of potassium is 5 into 10 to the power 14 per seconds. Okay, so you're supposed to find out the kinetic energy of the electron which is emitted. So what is happening? You have your potassium metal here, then a light of frequency 5.2 into 10 to the power 14 is falling on it. Some electrons are being ejected. You have to find out the kinetic energy of the electron being ejected. I hope you studied photoelectric effect in the last class, so you remember it. Okay, students, it's a slightly lengthier problem compared to the previous ones that you have done. So you can take 1 or 2 minutes, solve it, then let me know. You can also discuss it with your friends, but only talk about chemistry, please. Okay, students, do any of you have the answer? Okay, Shillong has the answer, which is correct. Good. Okay, students, just to give you a hint, the formula we're going to use here is kinetic energy, which is actually nothing but half mv square is equals to h nu minus h nu naught. Okay. Where nu naught is the threshold frequency. Okay, we have Kohima also answering, which is also correct. Perfect. Christukula, we're only waiting for you now. So for students who have done, I'm writing down the next question for you. Christukula, you can keep attempting this question in the meantime. Christukula, we still haven't received an answer from you. I hope you're not facing any problem. So the next question for rest of the students is, The threshold energy for photoelectric emission. Okay, Christokula also has given the correct answer. Perfect. Next question for all of you, quickly. The threshold energy for photoelectric emission of electron from a metal is given as 3.056 into 10 to the power minus 15 joules. If light of 4000 angstroms Okay. So here you are given that you have a metal whose threshold frequency, whose threshold energy is given to you as 3.056 into 10 to the power minus 15 joules, and you're falling a light of 4000 angstroms wavelength on it. You have to tell if the electron will be emitted or not. Okay, we'll solve the question after we get answer from you. So you should first at least try to attempt this. Okay, Christokula, you have given us a number. What is this number? The question says, will the electron be emitted or not? So you can also give us an answer of yes or no. Yes, if you think it will be emitted. No, if not. Okay. Okay, Christokula, we see you're performing, you're doing the question. Okay, students, I hope you're solving this question. Okay, we haven't received an answer from anyone yet. If you're facing any problem, you can always write it down and we'll explain it. Okay, Kohima and Shillong have given us the answer as no. They will not be emitted. Kristukula, can we have an answer from you? The electrons will not be emitted because the energy of the radiated light is actually less than the threshold frequency. And how you can calculate the energy of incident light is h nu, which is equals to hc by lambda. Okay. So students, if any of you have calculated the frequency separately, you actually don't need to do that. You can just put in the values of c and lambda directly here and then also calculate. So putting in this value, this comes out to be 4.97 into 10 to the power minus 19 joules, which is actually less than the threshold frequency that you're given. So no electrons will be emitted. Kristukula, we haven't received an answer from you. Are you attempting the question? Okay, moving ahead. If any of you were not, okay, Kristukula says no emission. Great. So moving ahead. We now have a slightly tougher question for you, where I'm sure you all will be able to do it. Okay. So the question is, you have to calculate the number of electrons, protons and neutrons in NH4 plus ion and phosphate ion. Okay, I hope you know NH4 plus ion is actually ammonium and PO4 3 minus is phosphate. Okay, both of them are very important groups. They are used a lot in chemistry. So, please tell me the number of electrons, protons and neutrons in both of them. Students, I hope you are attempting this. If you have any problem, Just put it in the chat box. Okay, we have an answer from Christukula, which is correct. Good. Okay, Christukula, quickly tell me the number of neutrons as well. Christukula, I think your second part answer is incorrect. Can you please check it again? Okay, students from other centers, I hope you're trying to attempt this. Okay, Shillong, your answer is correct. Kohima, please check the number of neutrons again. Yeah, okay, now you're correct. Neutrons is 7. Okay, great. So, for the first part, you have protons is equals to 11, neutrons is equals to 7, and electrons is equals to 10. So, I think all of you got this correct answer. For the second part, you have electrons is equals to 50, protons is equals to 47, and neutrons is equals to 48. Okay. So students, please again try to solve the second part and see if your answer matches this. Slightly tougher question, but if you were able to solve the first part, you should be able to solve this as well. You need to use exactly the same concept as the first part. Also, for this, you need to have the atomic number of oxygen and phosphorus. I hope you remember this. For the exam, you should at least know the atomic numbers for elements up to 30. Worst case, 20, definitely. Kohima, yeah, sure. We'll have a break after this part. So just quickly give me the answer for this part. When everybody understands this, you can all go for a break. Shillong, okay, you're not getting the second one. No problem. Okay. So let's try to solve the second one. It seems many students are having problem with this. Okay, so how do we go about this is, number of electrons in phosphate ion will be equal to, let me just give you the detailed explanation of how we actually calculate this. Electrons in phosphate ions would be equal to number of electrons in phosphorus atom plus 4 into number of electrons in oxygen atom, because we have 4 oxygen atoms here, and plus 3 due to the presence of negative charge. Okay. Now for phosphorus, the atomic number is 15. So you're going to have 15 here, the number of protons. For oxygen, you're going to have 8 into 4 gives you 32, plus 3 comes out to be 50. Okay. Similarly, the number of protons in phosphate ion would be equal to 15 coming from phosphorus individually, plus 4 into 8 coming from oxygen, and this would be equal to 15 plus 32 equals to 47. Okay. Similarly, now if I have to count the number of neutrons in phosphate, that would be equal to the number in phosphorus, which is 31 minus 15 plus 4 into 16 minus 8, which is equals to 48. Okay. We have the answer from Christokula, which is correct. Okay, students, so for this you actually need to know the mass number and atomic number of phosphorus and oxygen, which you should know. In your exam, it is not necessary that you will be given the value of mass number and atomic number for the elements. At least for the first 31, you won't be. Okay. Worst case, remember them for the first 21 at least. Okay. If you have any higher element coming in like uranium, then you will be given its atomic number and mass number both, because we don't expect you to remember that. But for all of them till 30, please try to remember them. Okay, students. So if you've understood this, and if you don't have a doubt, we can proceed with the break. If you have any question, please let me know in the chat box. Okay. Okay, students. So no doubt till now. So you guys can now quickly have a 10-minute break, and after that we will again meet back and solve some more questions. Okay, just walk around, drink water. I'm so sorry for the terrible smiley. Okay, please go refresh yourselves and we'll meet back again in 10 minutes. Hello students, are all of us back now? Okay, I hope you had a nice break and you're rejuvenated again to study chemistry. Okay, so now here is a slightly more trickier question for you, but I'm sure you all will be able to solve it because I see all of you have very nice mathematical skills. So the question here is, this is actually a question which appeared in, I think last to last year NEET paper. When a certain metal was irradiated with light of frequency 3.2 into 10 to the power 16 Hertz, the photoelectrons in this case had twice the energy as emitted when the same metal was irradiated with light of frequency 2 into 10 to the power 16 Hertz. You have to find threshold frequency of the metal. Okay, so slightly tougher question, but not tough enough that you won't be able to solve it. When a certain metal was irradiated with light of frequency 3.2 into 10 to the power 16 Hertz, the photoelectrons had twice the energy as emitted when the same metal was irradiated with light of frequency 2 into 10 to the power 16 Hertz. What is the threshold frequency of the metal? Please start solving. If you face any problem, just let us know in the comment section or the chat section. If you're able to solve it, well and good. Let us know the answer. How is it going, students? Have you figured out how to solve it? You will have two equations being formed, which you will need to equate and then find out the threshold frequency. Christokula, I'm afraid your answer is incorrect. Please check again. Maybe you must have made a calculation mistake. So, just giving a hint, you will have kinetic energy for the first case as, since it's h nu, where nu naught is basically the threshold frequency, and kinetic energy 2 will be equal to and then you are given okay, so you just need to equate the two equations. H will get cancelled, so you actually don't need to ever put in the value of H and complicate your calculations. You can just let it be H, it will get cancelled. Students, do we have any progress? Christokula, did you try to attempt it again? Great. Christokula, your answer is correct now. Shillong, Kohima, do we have an answer from you? Shillong, great. Your answer is also correct. Kohima, are we attempting the problem? Okay, Christokula, my name is Garima. Okay, students, shall we move ahead? Kohima, I hope you've written down the question. You can keep attempting this and let us know if you face any problem. Shillong and Christukula students, I'm writing down the next question for you now. Okay, so again, it's a slightly tougher question which has some mathematics involved. But again, nothing to worry. We all have great mathematical skills. An element with mass number 81 contains 31.7% more neutrons as compared to protons. What is the atomic symbol of this element? So you have to assign an atomic symbol to this element. Okay, so an element with mass number 81 contains 31.7% more neutrons as compared to protons. Assign an atomic symbol to this element. Shillong and Christukula, you can start attempting this. Kohima, we haven't received an answer from you. If you have any problem, just let us know. I hope your chat box and internet is working fine. Students, how's it going? If you're facing any problem, just let us know. You can of course discuss amongst yourselves. If you want a hint, if any one of you stuck, let me just tell you how to proceed. You are given that the mass number is equals to 81. This implies that 81 is equals to the number of protons and the neutrons that you have. But now we're not given the number of either the protons or the neutrons. So what do? We assume. Let the number of protons be equal to x. Okay? So this means that the number of neutrons would be equal to x plus, because we're given that the number of neutrons is 31.7 more. Okay, so this will be number of protons plus 31.7%, which is 31.7 by 100 of x. Okay, I hope you understood this. This is basically just forming a simple linear equation which you must have studied. So now all that we need to do is we need to put in our values, which means number of protons plus number of neutrons should be equal to 81. Solve this equation for x. Even if you're not able to assign a symbol to it, it's fine for now. At least tell me the number of protons, neutrons, basically the atomic number and the mass number. That should be fine. Okay, Shillong has an answer which is correct. Great. Kristukula, Kohima, we're waiting for you. Shillong, were you able to solve this? If you want one more example or one more similar question, let me know. I can give you, just to ensure that you are aware of the exact method to be followed. Okay, great. I really like Shillong students. It seems you are very excited to solve problems. Same goes with others as well. All of you also seem to have great mathematical skills. Okay. So the next question, similar one to this, just to ensure that you have understood. An ion with mass number 37 possesses 1 unit of negative charge. If the ion contains 11.1% more neutrons than electrons, find the symbol of the ion. Christokula, we haven't received a response from you. I hope you're able to solve the question and it's just a net issue that you're facing. An ion with mass number 37 possesses 1 unit of negative charge. If the ion contains 11.1% more neutrons than electrons, what is the symbol of the ion? So again, even if you just give me the number of protons, electrons, neutrons, it's fine. And just like before, you will have to assume something. Okay, you have to take either neutrons or electrons as X, and then you will have to solve the question. How is it going, students? Okay, in case any of you is stuck, let me give you a hint. You will have to let number of electrons in this ion as X. Okay, because you're given that it has more neutrons than electrons. So whatever thing you're given as standard, you have to take that as X. This implies that number of neutrons will be X plus 11.1 by 100x, exactly like we did earlier. Okay? Now you're given the mass number and you can form the equation for X. Okay, also one more thing here. Since you're given the number of electrons, you have let the number of electrons as x, and you're given that you have 1 unit of negative charge. This means your number of protons would be x minus 1. Okay? You have a negative charge, which means you have more electron. So your proton will be 1 less. So it will be x minus 1. I hope this information is enough for you to give me the answer now. Oh, we have Christokula back joining us. So, Christokula, your mass number is actually correct. Atomic number is incorrect. Please just check it once. Okay, we have an answer from Shillong, which is somewhat correct. Okay, students, so I think most of you were able to solve the question. From this equation, you will actually get x as 18, which means that 18 electrons are present in your ion that you have, which means that the number of protons that you have would be 18 minus 1 from this equation. Therefore, number of protons would be 17. Okay? And also number of neutrons comes out to be, I'm sure you have calculated this correctly. It will be number of neutrons plus protons will actually come out to be 37. So the element that you have is 3717 Cl minus 1. Okay. So Christokula, your number 37 was correct. I think you just forgot to encounter one negative charge which is given in the question. And Shillong, you guessed it Cl, it's correct. Just ensure that you also mention the charge that you have minus 1. Okay? Okay, I think all of us have understood now. So moving ahead. Next question. From the photoelectric effect. Electrons are emitted with zero velocity from a metal surface when it is exposed to radiation of wavelength 6800 angstrom. calculate the threshold frequency and work function of the metal. Okay, please try solving this question. And in the interim, we have a question from Chris Tukula, a doubt. They are saying that the mass of Cl is actually 35.5. Okay, this is actually correct and a very good doubt in fact. So in the previous question, you must have noticed that for mass number 35, we have assigned it that it's Cl. However, if you see it in the periodic table or in any of the books, the mass of Cl is given to be 35.5. Now, why this discrepancy arises is because mass number is actually equal to the number of protons and the electrons. Alright, now all the Cl atoms are always going to have the same number of protons, which means they are going to have same atomic number. Okay, that's why we say that atomic number is actually an identity of the element. It's always going to be the same. However, the number of neutrons can be different. So actually some of the Cl ions that I take in a sample can have a different different number of neutrons. Okay, if I take a separate sample, some of the neutrons atom there, some of the chlorine atoms there can have a different number of neutrons. So therefore their mass actually varies because of this. And the number that you see in your periodic table or in your books is actually what we have calculated using average of all the Cl atoms that we have. Okay, so the number 35.5 has actually been arrived at if we have taken the average of all the Cl numbers that we have. And how we did that is, we found out that let's say the number of Cl atoms that have mass as 35 is 100 and the number of Cl atoms that have mass as 37 is, let's say, 50. So you just calculate the average of that or the mean of that. It came out to be equal to 35.5. So we decided, okay, all of us are going to take the mass of Cl as 35.5 for all our calculations and similar purposes. Okay, and I think this thing you must have already studied in your first chapter of chemistry when you must have studied percentage abundance of different elements. I'm sure you must have, because it's actually a very famous question that comes in the exams. If you have, good. If you haven't, please let me know right now, because we will attempt a question for that as well. Now it's a very important question. Although it's not from this chapter, it's from the first chapter, but still you should know this. It in fact comes in, I think, class 9th as well, when you study atoms and molecules, or when you study isotopes and isobars. So Cl actually has different isotopes, because of which its mass is different. Okay, so students, if you're clear with this concept, let me know. If you're not, we should first attempt a question on this concept because it's important and very basic. If you're clear, then please move ahead and try attempting the question, the recent question that I gave you of the photoelectric effect. How's it going, students? It's a comparatively simple question compared to the difficult ones that we just attempted. So I hope you're able to solve it. Just to give you a hint, in case you are stuck anywhere, if you're given that the electrons are emitted with zero velocity, then this actually means that the wavelength that you're given is the threshold wavelength. Okay? This means that whatever wavelength you're providing is just enough to emit an electron, which means it is threshold wavelength. So you have threshold wavelength, let's say lambda naught, as 6800 into 10 to the power minus 10 meters. Your threshold frequency would be equal to C upon lambda naught. You can just plug in the values and calculate this. And your work function, let's say W naught, would be equal to H nu naught. So students, actually the formulas in this chapter are very simple and small. You can easily remember them. The trick is calculation. You will see that there are some very bad numbers here in this chapter. You know, the value of H, the value of frequency that comes in, and you have to calculate 1 upon frequency. And also you have to pay attention to the power of 10 as well. Okay, so I understand it's a little difficult, but you have to practice more numericals, and only then will you be able to prevent any silly mistakes and score in this chapter. Christukula, your answer is correct. Your power of 10 is not. Please just check it again. Although it's very close to the correct answer though. Okay, Shillong has a doubt. Explain zero velocity and wavelength. Okay, so basically, the basic process of photoelectric emission, how it takes place is, let's say you have any metal, you put a light of any frequency or wavelength on it. Now, if this frequency is more than the threshold frequency of the metal, the electrons will get emitted out of it. Okay, if it's less, no electron will be emitted out of it. And whenever an electron is being emitted out, it will have some kinetic energy. Why? Because there is a movement associated. Whenever there is a movement, there is a kinetic energy. However, in this question you are given that they are emitted with zero velocity, which means that the electron has just emitted and it has stayed there. It has no velocity and therefore no kinetic energy. Okay, understand it like this. Kinetic energy is actually half mv square. You're given that the velocity here is 0, which means that the kinetic energy is 0. So if you have a metal like this, light is coming in, electron is being ejected, but it's just staying there stationary. Okay? So you have basically your kinetic energy as 0. If you know your equation of work function and threshold frequency, just plug in kinetic energy 0 there and now try to solve it. If you still have a problem, please don't be scared to ask again. Christokula, your answer is actually correct. Okay, correct. Christokula, good. Shillong students, I hope you're now able to understand this. Okay, students, just to give you a hint, in case any of you is stuck, we discussed that your lambda naught or the threshold wavelength is equal to 6800 angstroms or 6800 into 10 to the power minus 10 meters. Okay, please don't get confused between threshold frequency and threshold wavelength. Okay, in some questions you might be given threshold frequency, in some questions you might be given threshold wavelength. Basically, both wavelength and frequency are characteristics of a particular light that you have. So for a single light, same type of light, I can either give you frequency or wavelength. The formula or the equation does not change. Okay, either you will be given frequency or wavelength. You just need to see which formula to apply. Okay, so here since I'm given lambda, I will plug in frequency as C by lambda naught. So my threshold frequency would be equal to C by lambda naught equals 3 into 10 to the power 8 meters per second upon 6800 into 10 to the power minus 10 meters. This comes out to be 4.41 into 10 to the power, plus 14, 10 to the power 14 per second or second inverse. Okay, and similarly work function will be equal to h nu naught, which is equals to 6.6 into 10 to the power minus 34 joule seconds into 4.41, the value of frequency that we just calculated, and this will be equal to 2.92 into 10 to the power minus 19 joules. Okay, basic calculations that you have to do here. Are we all on the same page? Students, if any of you have any doubt, please let me know. So, the two final answers that you have are threshold frequency will be 4.41 into 10 to the power 14 per second, and your work function will be 2.92 into 10 to the power minus 19 joules. Shillong students, have you understood? Please tell me yes or no. Okay, great. All of you seem to have understood, and all of you seem to be a little restless also now. Okay, I understand atomic structure and the questions related to it can be a little difficult, but practice is the key. You have to practice more and more questions. And in case you have any doubt, you can always come back to us and post the doubt in our WhatsApp group, or come with your doubt in the next class. We'll be happy to discuss it and solve your doubts. So yeah, that was all about for today. I hope you had a nice class, and yeah, enjoy your day. Bye bye everyone.